Hello everyone. In this video, we are going to study regarding the design of staircase. So let us start with the presentation. So first let us see what do you mean by staircase, what all different types of staircase we have, and how we are going to calculate the span and what all loads they are going to come on the staircase. So first let us start with the staircase. A staircase is a means of giving access to different floors or levels of a building. So if you come see one building, we are going to have different floor. That is first floor, second floor, third floor, fourth floor, and all. So in that, if you want to go from one floor to another floor, there has to be certain access. So for that purpose, what we do, we are going to use this staircase. So what happens is that in almost every building, staircases are required. This is one of the essential structural component. It consists of number of steps arranged in a way that a person can move from one level to another. The arrangement of the steps is as per the convenience, standard, and the space available. Staircase flights are generally designed as slabs spanning between wall supports or landing beams or as a cantilever from a longitudinal beam. So this further in the presentation I will try to cover. Next is the staircase fulfills the function of access between the various floors in the building. Generally, the flight of steps consists of one or more landing provided between the floor levels. Generally, we may provide one landing or we may not have a landing also. So directly we may have 20 to 24 number of steps, so that directly we go from one level to another. So this type of staircase also we have. So if now further we'll try to see the structural components of a staircase. So first one is the tread. Tread is nothing but the horizontal portion of a step where the footrest is referred as tread. So usually what we do, we are going to provide a width of 250 to 300 mm. Then next is riser. So if you see in the staircase, we are going to have steps like this. So this is nothing but the tread we have. Riser is nothing but the vertical distance between the adjacent treads. So if you see, this is the tread, this is the tread. So vertical distance between these two treads is called as a riser. Its value, it is going to vary from 150 to 190 mm depending upon the type of the building. So if you are going to increase the depth, then it becomes very difficult to move from one tread to another. The width of stairs is generally 1 to 1.5 meter, and in any case not less than 850 mm. So minimum we need to provide 850 mm. Public buildings should be provided with larger width to facilitate free passage to users and prevent overcrowding. So if you go for commercial buildings or public buildings, so probability will be that we may have overcrowding. So therefore, larger width has to be provided. For residential building and all, we can provide the minimum width. Then next is going. Going is nothing but the horizontal projection of an inclined flight of steps between the first and last riser. So if you see, further I'll show you in the figure. A typical flight comprises two landings and one going. So what happens is that if you take any staircase, so what happens is that if this is one flight, so we are going to have one landing here, at the end we are going to have another landing. So we are going to have the number of steps like this. So this we call it as a going. This we call it as a going, and this is the landing we have, right? To break the monotony of the climbing, the number of steps in a flight should not generally exceed 10 to 12. So what happens is that, so instead of keeping all 20 to 24 steps at a stretch, as so as to avoid the monotony, what we do, we are going to divide into 2 or 3 flights. The tread riser combination can be provided in conjunction with, first one is waste slab type, or next is riser and tread type, or next one is isolated cantilever tread slab, or double cantilever precast tread slab with a central inclined beam. So the tread and riser combination can be provided with these combinations. So let us see now. So first one was waste slab. So if you see now, this is the riser tread we have. So this can be provided with the waste slab. So here you can see at the bottom the distance, what you can say, from this what you can say dotted line to this, we call it as a waste slab. So here what happens is that waste slab has been provided along with this riser and tread. So second one is riser and tread type. So in this, if you see, so here there is no waste slab. So if you see riser and tread we have, riser and treads we have here. So this is another type of staircase. Then next is isolated cantilever tread slab. So here what happens is that we may have like if you see, this is the landing treads, you can see isolated cantilever tread riser type. So here what happens is that, for example, if this is the wall or support beam we have, so from here we are going to have the what you can say this cantilever. This will be the cantilever which is projecting from a beam or a wall support, right? This is the isolated cantilever. So here on this side we don't have support, on this side we will not have support, only on one side we will have support, other side it will be free. So therefore it is as isolated cantilever tread riser type. Then next comes is fourth one, that is double cantilever precast slab on an inclined beam. So double cantilever, as it says, for example, we have to have central beam. So the tread what we have, it will be cantilever on both the sides. So here also, this side also it will be free, this side also it will be free. On both the sides we are going to have the cantilever. Only at the central portion we are going to have the beam. Then next is, you can see, this is the typical flight of a staircase. This horizontal distance we call it as the tread, vertical distance we call it as the riser. So this will be the landing which is being provided. This is the one flight, typical flight in a staircase. Then next is the geometrical classification of staircase. So we may have single flight staircase. We may have single flight staircase. So you can see now here only one single flight we have. So here we are going to have number of risers and treads. At the end we are going to reach to the next level. Only one single flight we may have. Then next is quarter turn staircase. So if you see, this is one flight and this is another flight. So here we have taken the quarter turn. Then next is we have dog legged staircase. So here you can see we have one flight, landing we have, then next is another flight. So this is called as dog legged staircase. Then next is we have open well staircase. So here you can see, here we have one flight, landing, next flight, landing, next flight, landing, again next flight, landing and flight we have. So here you can see we have the open well staircase. These are the basic geometrical classification of staircase. Then next, as we are going to design the staircase, so let us try to study the structural behavior of staircase. So staircase can be grouped depending upon the support conditions and the direction of major bending of a slab component along the following categories. So what happens is that the staircase can be grouped upon the support condition what we provide, as well as the bending, how it takes place, bending of that slab, whether it is going to bend longitudinally or transversely. Based on that we can have following categories. One is staircase slab spanning longitudinally along the slope line. So for example, if this is landing, this is staircase, flight, again landing we have. So along this line, so whether if it is going to bend in this way, that is longitudinally along the length, or perpendicular to that, that is staircase slab spanning transversely. So slab width wise with central or side supports. So we may have these two types of categories based on the support condition as well as the direction of bending. So this is going to bend longitudinally and this is going to bend transversely. First, let us see now staircase slab spanning in longitudinal direction. So in this type, the inclined stair flight together with the landings are supported on walls or beam as shown in figure. So here if you see, this is the landing we have, riser, tread we have, flight we have, next we have landing. So here if you see, the support, it is being provided at the end. At the end, the support is being provided, either you may have walls or beams. So if you see the plan view, we have what you can say wall support, we have landing, flight, or what you can say going, we have landing, and again supports. So the effective span will be the center to center distance of the support, center to center distance of the support. So this is what we call it as a effective span. So in this type, the inclined, or you can say the effective span to be considered in the design computation is between the center to center of supports. Then next is a staircase slab spanning in the longitudinal direction. So that is what we have, staircase plans, what you can say slab spanning in the longitudinal direction. So in this type, the inclined stair flight together with the landing are supported on walls or beam as shown in figure. So if you compare to the previous part, here it was supported somewhere here in the previous part, but in this type of staircase, so what happens that if it is supported on the landing, what you can say in this type, the inclined stair flight together with the landing, it is supported either on the beams or a wall. So in this what you can say type, how to calculate the effective span. So the effective span is calculated, that is center to center distance between the supports, right? So for example, if you take, this is the table, like here if you see, this is the, you can take the effective span between these two. So now what will be this distance? So we have that is x and y and a span. How to calculate the span? So for example, now this is the landing, so let us try to take it as a half. Here x we have, then next is going we have, then next here on this side we can have it as a dimension, that is y. Then next, how to calculate the span length? How to calculate the span length? So for example, if this x value, if it is less than 1 meter, and y value if it is less than 1 meter, if this value is, if it is less than 1 meter, then span will be distance from center to center distance, that is going plus x plus y, going plus x plus y. Then next, if x is less than 1 meter, y is greater than 1 meter, right? If this x is less than 1 meter, y is greater than 1 meter, then what happens is that, so one thing what we can remember is, if the distance, if it is greater than 1 meter, that time we have to take it as 1 meter, so we are not going to exceed that, right? So here as y is exceeding, so therefore instead of, if it is greater than 1, we have to take 1 itself, that is going plus x plus, here we are going to take it as 1. Similarly here now in this case, x is greater than 1, x is greater than 1, but y is less than 1, therefore here we are going to have 1 plus going plus y, 1 plus going plus y. Then next, in both these things, that is x is also greater than 1, y is also greater than 1, then we have to take 1 here plus going. So from here till here, going plus 1 here and plus 1 here, going plus 1 plus 1. Then next is staircase slab spanning in the longitudinal directions, right? So same thing we'll see. So how the slab arrangement may be of a conventional waste slab type or riser and tread type between the support. The slab thickness depends upon the span. So what is the span? Just now what we have seen, based on that span, the thickness can be reduced by providing the intermediate support. If you are going to have larger span, thickness of that waste slab, it is going to increase. So as to avoid the thickness, more thickness, what we can do, we can provide certain intermediate supports. Alternatively, it is possible to provide supports to the landing slab in the transverse direction, right? So here if you see, uh, alternatively what we can do, we can for example, if this is the case, So here also we can provide certain support so that span, what can say, of the staircase reduces, then we can provide the lesser thickness. In such cases, the effective span to be considered according to IS 456 2000 clause 33.1b is given by L is equal to G plus X plus Y, where G is nothing but going, X or Y is nothing but the half width of the landing, as we have seen earlier. Then next is staircase slab spanning in the longitudinal direction. This is about the open well staircase. In the case stairs are open well where span partly crisscross at right angles. So here you can see this is at right angles. When the span partly crisscross at right angles, the load on areas common to any two such spans may be distributed as one half in the each direction as shown in figure. So for example, if you take the loading, so here if you take, this is one flight we have, this is another flight we have, right? So now this will be the common portion, this will be the common portion. So similarly this will be the common portion when you consider this as well as this. Then next is when it comes to the loading of this portion, so how much loading has to be taken? So half loading has to be taken on this, half loading has to be taken on this portion. Similarly half has to be taken on this portion. So therefore here if you see, for this loading will be W, for this span loading will be W for this going. When it comes to landing, from here you can see the load will be W by 2, half load will be transferred here, similarly half will be transferred here. So therefore here if you see, here this will be W by 2 up to this landing. After that you are going to have full load, that is W. Up to this we are going to have full load. Again in this portion half loading W by 2. Similarly if you draw it somewhere here, so again from here it will be W. Next is it will be reduced, it will be coming somewhere here. So here it will be W by 2. Then next comes is staircase slab spanning in the transverse direction, right? So what happens is that in this they are grouped under the following, that is slab supported between the two edge beams or walls. So for example, if this is the flight we have, this is one flight we have. So here what happens is that the slab is supported on two sides. So here we have to have one beam and here we are going to have one beam. So here either we may have what you can say wall or beam. Longitudinally this is supported. Longitudinally what you can say, this is supported. Either it might be what you can say walls or it might be beams. That is one case. Or in another case, that is slab cantilevering on either side of a central beam. So for example, if this is the staircase, then what happens is at the central portion we may have the beam. So here what happens, this might be the beam. So from here we can have cantilever on left side as well as on the right side. Then next is a cantilever slab from a wall or a spandrel beam. So what happens is that, so for example, if this is the flight what we have, so here what happens that only on one side you may have the support, that is you may have the beam. So from this beam it will be the cantilever, this flight will be the cantilever. So in these types of slabs, width of the flight being small, that is 1 to 1.5 meter, the design thickness will be very small compared to the structural computations. So here we have seen two things. One is, for example, if I am going to draw the staircase somewhat here, if you consider this as one of the flight, this is landing, and these are the treads if you are going to show. Then what happens is that here we have seen two cases. So for example, if we are going to go in this direction, if you are going to cut the section somewhere here, right, if it is longitudinally supported and if it is transversely supported, so what is the if it is spanning in longitudinal direction as well as in the transverse direction. So when it is spanning in the longitudinal direction, this will be the case, so span will be very much higher, so therefore moment will be very much larger, so therefore thickness of the slab required will be very much larger. In the next case what happens is that, for example, if we are going to consider in this way, for example, if you are going to see it in this direction, if you cut in this direction, if the slab is spanning in the transverse direction, for example in this direction, if it is spanning, Then what happens is that, as always, what happens is that this width might be hardly 1 meter or 1.2 meters, so the span will be very much lesser. So therefore what happens is that thickness, if the slab is spanning in the transverse direction, then as the span is very less, the thickness required will be very much lesser. But therefore, but then also what we do, we are going to provide the nominal, what you can say, minimum thickness of 75 to 80 mm should be provided to resist the bending moment, or to we are going to provide the minimum percentage of the reinforcement. If you see, these are the three cases what we can have: slab span supported between the two edge beams, right? So this is the slab now, so it is supported on two edge beams. So here it is supported transversely, so here it is supported, so here we have beam and here we have the beam. It is supported on two edge beams or walls. Second one was, we are going to have the beam. From this we are going to have the cantilever. Then next we are going to have the central beam. So on both the sides we may have the cantilever, that is slab cantilevered from the central beam, slab supported on edge beam or wall, or slab cantilevered from what you can say, wall or a beams. Then next comes is, let us try to see what all loads they are going to act on the staircase. So first one is dead load. So dead load is nothing but the self weight of the stair slab concretes, which include the waste slab, riser, tread, etc. So we have to consider the self weight of the slab. That might be the weight of the riser, tread and the waste slab. Then next is the self weight of finishes. So for flooring and all, we may add certain self weight, that is 0.5 to 1 kilonewton per meter square. We have to add up the dead loads. Then next is regarding the live loads. So according to IS 875/1987 part 2, the live load to be considered is uniformly distributed load of intensity 5 kilonewton per meter square if it is public building, and 3 kilonewton per meter square for residential building. 5 for what you can say, public buildings, and 3 for residential buildings. Where the, if for example, if the specified floor loads does not exceed 2 kilonewton per meter square, right, then what happens is that the staircases are not liable for overcrowding. So for example, if you have any public building and all, if probability is that there may be overcrowding, then you have to specify load, that is 3 kilonewton per meter square. If you are going to provide 2 kilonewton per meter square, so then it is not liable for the overcrowding. Then next is load effects on waste slab spanning in the longitudinal direction. Waste slab spanning in the longitudinal direction. What happens is that the thickness of the waste slab, what you can say, this thickness of this slab normal to the slope may be assumed as approximately, that is we can have L by 20 or L by 25, L by 20 for simply supported and L by 25 for continuous slabs. The steps are usually treated as non-structural elements. These steps what we have, these are not the structural elements, and only the thickness of the waste slab is designed to resist the load. So what we do, only the thickness of waste slab what we are going to provide, we are going to design this slab which is going to resist the load. So these are the non-structural elements what we consider. Nominal reinforcement is generally provided in the step to protect the nosing from cracking, comprising of 6 mm dia bars at 150 mm centers, right? So what happens is that so for this nosing, we may provide, sometimes we may provide certain 6 mm dia bars so as to avoid the cracking of this nosing portion. The waste slab, that is the sloping slab, is inclined at an angle of theta to the horizontal. So if you see, this is the slab which is inclined at an angle of theta with respect to the horizontal. In a flight, what you can say, at an angle of theta to the horizontal in a flight of stair spanning in the longitudinal direction as shown in figure, right? So if you see now, this is the slab which is inclined at an angle of theta with respect to horizontal. So for example, if you see, So the weight of the slab which is normal to the surface, so that we can call it as ws, weight of this slab. Then next, waste slab. Then next is, if you want to calculate its vertical component, what will be its vertical component, we can resolve this. So if this angle is theta, then this angle will also be equal to theta. Then next, if you calculate this component, inclined component, that is if you want to resolve this, ws into cos theta, so this distance will be, this inclined distance will be square root of r square plus t square into ws divided by t we have, right? So this formula we can remember so as to calculate the weight, that is self weight of the slab, self weight of the slab in the, on a horizontal span. So where r is nothing but, what you can say, riser we have, this is the riser height. T is nothing but the tread we have. ws is nothing but the self weight of slab, that is per meter. As we are designing slab, we are going to consider it as a per meter span. Then next, w, that is nothing but the self weight of the slab on a horizontal span. And theta is nothing but the angle between the sloping slab and the horizontal, angle between sloping slab and horizontal, that is theta. Then dead load of a slab on a horizontal span is expressed as this formula. This is the formula what we have. Then next is load effect on waste slab spanning in the longitudinal direction, that is self weight of the steps, what you can say, a triangular shape are computed. Then next is regarding this steps, so this will be the triangular portion, the self weight of this, it is being calculated, and their weight per meter length of the horizontal span is added to the dead weight of the slab. So the dead weight of this slab, the triangular portion is being calculated, and this is being added as the dead load additional to the self weight of the slab along with the live load. For that, what we do, for that loading, we are going to calculate the dead load of this waste slab of this riser and tread triangular portion, plus we are going to put floor finishes, we are going to take the live load. For this, we are going to calculate the moment. For that, we are going to design the reinforcement, and the detailing, it is being done in this way. So you can see here now, here this is the bottom portion, it is going to go straight, and it is going to go straight to the top, this will come here. The next, bottom reinforcement, you can see top reinforcement, it will be provided somewhere here. Then next is this bottom reinforcement, it will come to the top, and it is going to come here, right? So this what you can say, the line what you are seeing, that is nothing but the main reinforcement, and the circles what we are seeing, that will be the distribution stair, what you can say, reinforcement. So the supports might be either beam or a wall. So then next is load effects on waste slab, that is spanning transversely. The load acts normal to the waste slab which bends in a transverse plane normal to the sloping surface of the slab. As what happens is that in the transfer direction, span will be less, the bending moment will be less. So therefore what happens is that the beams are designed to resist this bending moment and are provided transversely either at the bottom or top, depending upon whether the slab is simply supported or cantilever from the support. So if you see the slab in the longitudinal direction, the length is larger, so therefore depth required will be very much larger. But when we come to the transverse direction, the span will be very much lesser. So usually hardly you may have a span of like 1 to 1.5 meters. Therefore what happens is that thickness of this slab, it will be very much lesser, but as a minimum requirement what we do, but from practical consideration, if you see, a minimum thickness of 75 to 80 mm minimum depth of the slab is provided with the minimum reinforcement as per IS 456 code. So these are the minimum what you can say requirement which has to be satisfied so as to design the staircase.